Theorem number 1. A line drawn from the center of the circle. A line drawn from the center of the circle, perpendicular to a chord bisects the chord. A line drawn from the center of the circle perpendicular to a chord bisects the chord. So if I were to draw to represent this statement, this is our center and a chord. We have chord AB. What is meant by the word chord? When we say a certain line is a chord, what can you tell? It's a line that is drawn from the center, not passing through the center to the circumference length. That line is a chord. Okay. So we have center O, and we are drawing a line that is perpendicular from the center perpendicular to the chord. So I will explain what bisecting means. Okay. Now, when we say a line is bisecting a certain angle, it means we are splitting into two equal halves. Understand? So we know that angles on a straight line, they end up to 180 degrees. So if this one is 180 degrees, and then I'm introducing a perpendicular bisector to this angle. So meaning the line is going to be drawn perpendicular. It means this angle will be 90 degrees, and also this one is going to be 90 degrees. You understand why we have a 90 degrees here? Alright. So what we want to do here, we want to required to prove that I'm just saying this one is D, that AD is equal to DB. We want to prove that AD is equal to DB. This is theorem number 1. So then how do we provide the proof? The first thing you must do is to do a construction. You must construct. So we want to produce two triangles. So how do we produce these two triangles? Construction. Now, what are we going to construct? We need to join. OA and OB by means of a dotted line. So you come, you draw, you have your OA, and also your OB. As a result, two triangles now. We have triangle OBD and triangle ODA. There are two triangles now. Now that I want to prove that two sides are equal to each other, I go back to grade 9, congruence. How do you prove a congruence? You need to look for a side that is equal to the other side in the triangle. Then you also look for an angle. Then also another side. Or you can prove two angles at a side. Or you prove two sides and an angle. So when you are proving a congruence, you need to maintain an angle at a side and also another side or another angle. You understand it? Alright. So now I have two triangles. I'm going to say my proof in triangles O, D, A, and triangle O, D, B. Between these two triangles, fact number one, OD is equal to OD. It's a common side, right? Yes. So I'll say OD is common. OD is common. Number 2. Now that we drew a line from the center bisecting the chord, we had angle D1, and this one is D2. So angle D1 is equal to angle D2, which is equal to 90 degrees. It was given that angle D1 is 90 degrees. Alright. Then OA is equal to OB. OA is equal to OB, radi. Now when we have two radiuses which are equal, we don't say radiuses, it's radi. When it's a single line radius, plural means which means they are two now. You understand it? So your radius will always be equal in what? In length. You understand it? Yes, what is the radius? A line drawn from the center to the what? The circumference. It is a what? It is a radius. So if this one is a radius and also this one is a radius, then those two radii are what? Very good. Alright. Now we have proved that OP is common, D1 is equal to D2, which is equal to 90 degrees, and OA is equal to OB. We can now say, therefore, triangle ODA is congruent to triangle O what? ODB. What is the reason? Right hand side. Now, understand this. ODB is a right angle triangle, right? Because we have a 90 degree here. And so is O what? OAB. It's a right angle triangle. Now on these two right angle triangles, we talked of a what? Of a side, right? And we talked of the radius, which is the hypotenuse in other words, right? And we talked of the what? A right angled triangle, which is D1 and what? And D2. Hence, our reason is right hand side, right angled hypotenuse and the side. Then we can now say therefore AD is equal to what? To DB. The reason OD is a perpendicular bisector of what? AB. So in other words, AD is equal to what? To DB. And also these two are what? Are equal to each other. This is theorem number 1. Any questions? Or a line drawn from the center bisects the chord, which is a line drawn from the center bisects the chord because of this statement. This statement is going to be a reason. So for you to understand the reason, you must be able to provide a proof for that particular reason. So now you understand why we are saying AD is